So here we have a new announcement here, the Computex 2018. Hi, so who are you?
My name is Deepu Tala. I'm the general manager for Jetson and Intelligent Machines.
So this board there, what's special about this board?
So this is the world's first intelligent machine processor that's been designed for robotics, and it's called Jetson Xavier that our CEO Jensen Huang just announced earlier today. Very powerful computer for the next wave of intelligent autonomous machines.
So this board is inside here?
That's correct. So
and
this board,
is this with the cooling, or what is this?
This is the full developer kit. So this is the full computer, powerful computer based on a desktop Linux operating system, and it has powerful processors starting with our Volta GPU with tensor cores for deep learning and computer vision. It also has 5 other processors in addition, 8 CPUs.
Yeah. And what are all the connectors you have around it?
This is all different connectors from HDMI to PCIe Gen 4 to USBs to Ethernet, gigabit Ethernet.
This is a PCIe there? What is this?
Yeah, this is a USB 3. This is the HDMI, and it has from this connector at the here you can connect to all of the different PCIe Gen 4 Express. So it comes with a lot of different peripherals.
What do you have in there?
These are different components in there again. There's a different development board in there. It has 16 gigabytes of LP DDRAM 4X. It's got 32 gigabytes of flash. So it's a full desktop Linux computer. It's a powerful as a GPU workstation that you can use for development. So this is all you need essentially to develop all these intelligent autonomous machines.
So it's a Linux based on Ubuntu that you are optimizing?
Yes, this is based on 1604 Ubuntu distribution, and it's called Linux for Tegra. So if you go to Nvidia.com and search for Jetson and Jetpack, you'll be able to download the full desktop operating system for Jetson.
So is this 20 times faster than the TX2?
Previous version, that's correct. So this is 20 times faster and also 10 times more energy efficient than the previous version, which is the Jetson TX2.
So how does it compare with the ARM chipset that's right over here? Because if there's any chance, is it exactly the same ARM chipset?
Yeah,
or
it's
is
the
it
same.
small?
What's in the Nvidia Drive Xavier has the same.
Right?
Yeah.
Let me try. So where's the ARM chipset? Inside here, right?
That's right.
Exactly the same?
That's the same chip. That's the same chip that's inside, and here's 2 chips, 2 Xavier SoCs, and these are Volta GPUs, discrete GPUs.
So is it the 20 nanometers?
It's a 12 nanometer FinFET TSMC.
12 FinFET.
That's right.
And those are the huge, famous. If you can grab this one. This is a Volta. What do you call it?
V100.
V100.
Yes.
Which is the most powerful GPU in the world, right?
That's correct. 12 FinFET, 800 millimeter squared, the largest single chip ever manufactured, and this is what's powering, the data centers and cloud. It's what's in our DGX2. This is what's in our DGX2. 8 copies of this, and it's all sorts of.
So the DGX2 has 2 of these inside.
2 of those. 16 volt. Yes. 16 volt V100.
Is there an x86 processor somewhere?
Yeah, inside. So this one connects to an x86. Inside there is also a Xeon Platinum Xeon 2 core inside.
But now this Volta architecture right here, you have it right in there in your little board.
That's correct.
How many cores is this one compared to this one?
That one, the V100 has 8,000 cores, and this one has 512 cores.
So, because the TX2 had what do you call it, Pascal?
Yes, the TX2 had a Pascal that had 256 cores. So this one, Xavier, has a 512 core Volta GPU with tensor cores. Because we've added tensor cores for advancing deep learning and artificial intelligence, and then we also have deep learning accelerators. Combined with all of that, we are able to provide a performance that is more than 20 times the previous generation Jetson, and then also increase the energy efficiency by more than 10 times.
That's when you combine everything, the CPU, GPU.
No, just all of that. No. The whole thing, the whole computer there operates in under 30 watts. It has different modes of operation.
Is that the same as before?
The previous generation could go up to 15. This one we can do a 10 watt configuration, a 15 watt configuration, or a 30 watt configuration. And as a developer, you can configure anything in between. So you can go as low as 10 watts for not just the chip, but the whole module, the whole computer.
So just the GPU alone compared to Pascal you had before, what is the performance increase?
So at the system level, right? So we're talking about at the system level, we are able to deliver more than 20 times the peak performance and 10 times the energy efficiency. So at the end of the day, as a developer, if you're developing an intelligent machine, if you're a programmer, you need CPU, you need GPU, you need memory, you need the whole computer. So what I'm talking about, the 20x is the computer.
And how is this one, what is this?
So this is basically the module. This is the inside of the module. So when you buy this one. This is basically has the thermal transfer plate. So this is what's inside this.
So you buy that?
But this is what's plugging into the developer.
You plug it in?
You plug it in. It's inside. This one is inside this.
So that's the developer kit, but
the developer kit.
You can run like this. You don't need the. Is this a big cooling?
Yeah. So basically, what happens? So this is the developer kit. So this is what the module is. When you eventually build a product, you buy this and you build whatever form factor you want to build. So this is what you buy. This is the brain, and then you plug it into your motherboard. This one is the complete developer kit.
But what is the ARM processor, the octa-core that you're doing right here? Is this a custom ARM core?
Yes, this is based on the Nvidia custom.
It's not a big little kind of.
It is not a big little.
It is big ones.
8 big ones. It is based on Nvidia custom implementation of the ARMv8 architecture.
And can you say something about the performance just of that ARM?
Yeah, it is a very high performance ARM. It is higher than this typical ARM processor that you get. And actually we have released this information. If you go on the Nvidia webpage now, you can actually see the performance of the ARM CPU in it. It's a very high performance ARM CPU.
So this is, what are all these chips you're seeing around here?
Oh, these are just all the different inductors and the different things involved. So here you see, this is the Xavier SoC. Here you see different DRAM, 8 of them. All of them combined together gives you 16 gigabytes of capacity and 137 gigabytes per second of bandwidth.
And here is a bunch of
all the power management circuitry and all the different inductors that's necessary to build a full computer.
It kind of looks like the CPU can just be plugged in, but it's not, right?
Yeah, it's all designed into the PCB.
And on the backside?
The backside is the connector. This is a 600 pin connector.
Is it a special connector?
It's a special connector that you can extend all the different IOs.
And also a bunch of
yeah, this is all the system that you need to build. These are all the different inductors and capacitors, passives that you need to build a computer. So we've simplified all that, and so you can just buy this as a full computer, and you can build your program this right away without having to go and having to design all of this hardware yourself.
So this is compact and light, and is designed to be in all kinds of robots,
drones, industrial, yes, delivery, inspection, manufacturing, agriculture, drones, medical devices, plenty of any autonomous intelligent machine that need AI capability.
There are already some amazing robots and drones on the TX2.
That's right.
A lot of really cool demos. So does that mean that the new ones are going to be 20 times better?
They can if they want to.
How better?
Like performance, right? So if you look at some of those things, you want to get, if you look at an industrial drone, for example, mission critical is very important because you are flying in unmanned areas and you should not be hitting obstacles. So the amount of neural networks that you want to run, very similar to a self-driving car, you want to have redundancy, you want to have diversity. So you want to run many networks in parallel. So that requires a lot of processing power. And you want to increase your sensors from 1080p to 4K, and you want to increase the number of imagers. Maybe you want to have radar, you want to have other sensors. So this allows you to now suddenly increase the amount of performance and reliability and diversity and safety.
So the Volta GPUs are right on the SoC.
That's correct.
And what other, you all have another kind of AI solution, which is a proprietary Nvidia AI?
Yeah, so what the Xavier has is there are 6 different types of processors. We have the Volta Tensor Core GPU. We have the CPUs that we talked about. In addition to that, it also has 2 copies of a deep learning accelerator, which, by the way, is open source. So it's proprietary in the sense that we use it first time, but it's actually open source. Everybody has access to the source code. They can build on top of that. If you don't go to nvdla.org, anybody can download the source and anybody can use those deep learning accelerators.
So it's an open source NPU?
It's an open source TPU kind of equivalent, a deep learning accelerator. Deep learning accelerator. In addition to that's the third processor. In addition to that, we have a vision processor. We also have a signal processor, and we also have video processors.
So the signal processor, for example, is like camera kind of.
Camera processing, image signal processor that can process 12 4K cameras in parallel.
Is there something like a DSP?
The DSP is the vision processor.
The vision
processor.
So and all the cameras and stuff would connect through.
Yeah, you can. There's different. So this is the 600 pin connector. Is what the idea is. You can bring out all the different interfaces you want, from PCIe to USBs to Ethernet to camera to display to the traditional like SPI ports and I2C, and all the peripherals are brought out from here, and you can flexibly bring it in any computer. So this is the developer kit. We bring it in a certain example. Right here, we bring out HDMI and USB 3 and Ethernet and some of the camera connector here.
What is the connector here?
Yeah, this is basically some of the pins that are brought out here. You can hook up cameras in here.
No.
No, this can hook up to different cameras. It's a camera connector, and here you can bring the different PCIs.
How's it designed to design a connector? It has to fill everything, or you can choose just an area?
You can choose anyone you want, but inside this developer kit, you'll have a pair, the reverse of this. This is the master computer, and you have the daughter card underneath this one.
So $12.99, right?
That's right.
That means it's very affordable.
It is affordable.
But then that's for the kids. But maybe just buying this alone would be lower.
Yeah, we haven't announced the price yet, but you can expect it to be comparable.
But this is specifically for kind of like robotics, AI kind of. It's
AI,
not for
powerful AI at the edge.
It's not suitable. It's really for the consumer laptop business, for example.
I mean, there are different other solutions for it, right? So this is targeted primarily for autonomous and intelligent machines.
Is this powerful enough to run a self-driving car, or?
Yeah. So you see the same in the Drive Xavier. This is the same one that's powering a level 3 and a level 4. Yes, it is powerful for a level 3 self-driving car.
Fully self.
Yeah, level 3.
Level 3.
That's right.